Hello, welcome everyone. My name is Sadar Sudi Muhammad, mathematics teacher. Today we learn about trigonometry. So, at the end of this lesson, you will be able to define sine, define cosine, and define tangent of a given angle. But also, you'll be able to define complementary angles. Also, you'll be able to evaluate the sine, cosine, and tangent of a given angle. But also, you'll be able to find relationship between three basic trigonometrical ratios. Before we proceed further, can you remember the basic three trigonometrical ratios? Well done. The basic three trigonometrical ratios are sine, cosine, and tangent. Now, from the given right-angled triangle, can you define sine, cosine, and tangent of an angle theta? Yes, sine is equal opposite of a hypotenuse. Cosine is equal to adjacent of a hypotenuse. And tangent is equal to opposite over adjacent. So, these are three basic trigonometrical ratios, and these are how they are defined. You are very great. Thank you. Now consider a triangle ABC in which angles A and B are complementary angles, i.e. A plus C is equal to 90 degrees. Oh, who can define complementary angles now? Yes, Muhammad. Well done. Complementary angles are two angles in which their measures add to 90 degrees. Now recall the definition of sine, cosine, and tangent. Yes, sine is equal to opposite over hypotenuse. So from the triangle here, sine A is equal to A over B. A is the opposite and B is the hypotenuse of the side there. Okay, yes. Yes, sine A is equal to A over B. A is A and B is the hypotenuse as shown there from the triangle. Now, what about cos C? Okay, now what about cos C? Yes, Salama. Come on, try it. Cos C is equal to A over B. Wonderful. Thank you. C is equal to 90 minus A. Remember. So, according to what obtained above, can anyone now establish relationship between sine of angle A and cosine of angle C? If A and C are complementary angles of the given triangle. Oh, bravo. Sine A is equal to cos C, which is equal to A out of B, or A over B. So the relationship established here is that the sine of triangle, the sine of angle is equal to the cosine of its complement. The sine of an angle is equal to the cosine of its complement. Now let us continue with tangent. From the given triangle shown, we found that sine A is equal to A over B, cos A is equal to C over B. So, if you take sine A divided by cos A, what is the result? Everybody try it. Well done. tan A is equal to sine A over cos A. Therefore, we found that tan of an angle is equal to sine over cosine of that particular angle. Is equal to the ratio of sine to cosine of that particular angle. Now let us continue. If sine A is equal to A over B, what about sine squared of A? Yes, sine squared of A is equal to A over B, the whole thing square. Yeah, what about cos squared A? Yes, try it, Fatma. Oh, wonderful. Cos squared A is equal to C over B whole square. Cos squared A is equal to C over B square. C over B, the whole thing square. Now let us sum them together, i.e. sine squared A plus cos squared A. So sine squared A plus cos squared A is equal to A and A over B square plus C over B square. But from the given triangle, A square plus C square is equal to what? Yes, it is equal to B square. And this is according to Pythagoras Theorem. Then sine squared A plus cos squared A is equal to B square over B square, which is equal to 1. Therefore, sine squared A plus cos squared A is equal to 1. And this is another relationship obtained between these trigonometric ratios. Okay, let's see an example here. We have example number 1 says, given that A is an acute angle and cos A is equal to 0.8. So we're supposed to find sine A and tan A. We're supposed to find sine A and tan A. Okay, good. We have cos A is equal to 0.8. But 0.8 into a fraction, remember, this is a decimal, and we can convert it into a fraction, and this is equal to 8 over 10. So that is cos A. Cos A is equal to 8 over 10. Remember that we have, from this lesson, we have got some relationship between cos and sine and tangents. And especially when we talk about complementary angles. So one of the relationship is that said cos squared A, so we can say from cos squared A plus sine squared A is equal to 1. Our target here is to work out on sine A, but the given is cos A. But from this relation, we have observed earlier that cos squared A plus sin squared A is equal to 1. So what do I want to find here is sine A. So we can say that this implies that sine squared A is equal to 1 minus cos squared A. Okay, so if we only want sine A, as we know, this is square root of sine, but our target is only to get sine A. So you have to produce square root both sides. So if you produce square root both sides, we will have sine of angle A equal to square root of square root. So sine A is equal to 1 minus cos squared A. Okay, so now we have sine A is equal to square root of 1 minus cos squared of A. But remember, we have our cos A here, which is 8 out of 10. Now we have to square it, so as we can put it in the square root. So sine A here, yes, so now sine A, sine of angle A, going to be equal to square root of 1 minus, remember this is cos squared A, but the value obtained here is only cos A, so you have to square it. So it will be 8 square over 10 square, the whole thing under root. So this is the same as 100, as we know 10 square. 10 square means 10 times 10, so it is 100. And minus here 8 square, which is 64. The whole thing over 100. If you find the LCM here inside the root, we have to put over 1 here. So the LCM between 10 square, which is 100, and 1 is 100. So finally we have 100 minus 64 over 100. So finally we have sine of angle A is equal to, so 100 here minus 64, that is 36. So we'll have square root of 36 over 100. And you all remember that 36 is the square of 6 and 100 is the square of 10. So finally we will have sine of angle A equal to square root of 36, that is 6 square, we get 36, so 36 square root is 6, and square root of 100, that is 10. So from here, number 1 here is already solved. You can see we were supposed to find sine A, given that cos A is equal to 0.8. So we only enabled to find sine A by using the relation obtains between sine and cos, and that is from the identity that says cos squared A plus sine squared A is equal to 1. So remember that. Now we have another thing to work out here, which is tan of angle A. Tan of angle A. So we have sine, we have cos. Now we are supposed to work out on tan of angle A. Okay, now good. So now we're supposed to work out on tan of angle A. Now we're supposed to find tangent, okay, tan of A. But do you remember what is the relationship between tangent, sine, and cosine, as we already described earlier? Very good. There is a relationship between tangent and sine and cosine, and we only say that the tangent is equal to sine of the same angle, which is A, out of cosine of the same angle, which is A. So tangent A is equal to sine A over cos A. So now we have got sine A, which is 6 out of 10, sorry. And we have the cos A, which is given from the question here. Cos A is 0.8, which is 8 over 10 in terms of fraction. So we can now work out on tangent A. Tangent A, as we say, it is equal to sine A over cos A, but we have already calculated what is sine A, and that is 6 out of 10, and this divide by cos of A, which is 8 out of 10. So if you rearrange it, this is equal to tan of angle A gonna be equal to 6 over 10 times 10 over 8. If you rearrange this thing here, you can see it is equal to 6 over 10 times 10 over 8, and we can see that this 10 and the 10 here simplify each other, and finally we have, but also we can simplify 6 and 8. So what is the common number here? The common factor, or the smallest common factor that can simplify both 6 and 8 here? We can see it is number 2. Number 2 here divides 6 without remainder, which give you 3. There are 3 2's in 6, and there are 4 2's in 8. So finally we have tangent of angle A equal to 3 out of 4. So therefore we can say that sine A is equal to 6 over 10, but we can put it into more simpler form, which is equal to 3 out of 5. Since if you simplify by 2 throughout here, by how many 2's in 6, 3, and how many 2's in 10, which is 5. And tan of angle A, this is equal to 3 out of 4. So the question here now is done, and you can see that we were able to calculate sine A and tangent A by just only taking the relation between these 3 trigonometric ratios. Okay, so now let us see another example here after we have done the first example. This example number 2 said, given theta and beta are acute angles such that theta plus beta is equal to 90 degrees and sine theta is equal to 0.6. Find tangent beta. So from the question here, you can see that theta and beta are acute angles. This means the sum of these two angles is equal to 90. If that's so, this means theta and beta are complementary angles. Theta and beta are complementary angles. I mean, the angles in which the sum, they make it 90. So if beta and theta are complementary angles, this means sine of angle theta is going to be equal to cos of angle beta, and this is equal to be 0.6. I think you can remember from the start of our lesson here in trigonometry, we discussed that one of the relationship obtained between these trigonometric ratios, I mean sine cosine, is that sine of angle A is equal to cos of angle B if and only if these two angles A and B are complementary angles. And here theta and beta are complementary angles. I mean the sum of these two angles is equal to 90 degrees. So sine of angle theta is equal to cos of angle beta is equal to 0.6. So from here we can get that cos of angle beta or beta is equal to 6 out of 10. Also again, if we take Pythagoras Theorem from sine squared beta plus cos squared beta, this is equal to 1. We have, so the sine squared beta is going to be 1 minus cos squared beta. So the same thing here, we can see that sine of angle beta equals to square root of 1 minus cos squared beta. So this is the basic relationship obtained in these trigonometric ratios, I mean between sine and cosine, that the sum, the square of their sum is equal to 1. But also if we have two complementary angles in a right angle triangle, then sine of the first angle is equal to cosine of the of its complement. Sine of the angle is equal to cosine of its complement. That's why we said sine of angle theta is equal to cos of angle beta, because beta and theta are two complementary angles in a right angle triangle. So from here we can have sine of angle beta equal to square root of 1 minus 6 over 10, but we have to square it. Remember, 6 over 10 is only cos of angle beta, but here we have cos squared of angle beta. We have to square that, and finally we have square root of 1 minus 36 over 100. And if you put it clear, you can have 100 minus 36 whole thing over 100 under the root. So finally we have sine of angle beta equal to square root of here is 64 over 100. 36, I mean 100 minus 36 is 64, and here we have 100, and we can have sine of angle beta equal to 8 over 10, and if we simplify it further, as we know, we are supposed to put the fraction in a more simplistic form, and here 8 and 10 can be simplified into 4 out of 5. Now from here we have sine beta and we have cos beta, and the question said find tangent beta. So it is simple, as we have discussed here from the first example. We have the relation between tangents and sine and cosine, and the relationship here said what? Do you remember that? If you remember that, the relation says tan of angle beta is equal to sine of angle beta over cosine of angle beta. So now everything here is there. We have cos beta, we have sine beta, just 4 over 5 divided by cos 6 over 10, if you remember, and this is equal to 3 over 5. So what remains here is just simplification and putting things in a clear way. We can finally have tan of angle beta equal to 4/5 times 5/3. So here and here simplify one another, and you'll have tan of angle beta equal to 4/3. Yes, that's good. So therefore tan of angle beta is equal to 4/3. So this is the required value we were supposed to calculate. So you can see here from both examples. The first example, we were given the same angle to find sine of the same angle and cosine of the same angle. But here, and tangent of the same angle, given sine of cosine of theta. But here we have been given different angles, but there is a relation between the two given angles, which is beta and theta, and the relation said theta and beta are complementary. And we said earlier there that the sine of an angle is equal to cosine of its complement in a right-angled triangle. If you remember this very relationship that we can observe from these trigonometric ratios, we can finally do any kind of question concerning trigonometric ratio by just involving or making some connection between sine, cosine, and tangents. So now, below here are some of your exercise, so as you can make a lot of revision at home. Make sure you do them properly. Number 1, given that cos theta is equal to 4/5, find sine of angle theta. Number 2, if sine alpha is equal to √2/5, find sine 90 degrees minus alpha. Question number 3, if cos theta is equal to P/Q and tan theta is equal to R/P, find sine theta. And question number 4 says, if tan beta is equal to K/square root of U and cos beta is equal to square root of U/m, show that m is equal to square root of K squared plus U. What have we learned today? We have learned today that sine of angle is equal to cosine of its complements. And the tan of an angle is equal to the ratio of sine to cosine of that particular angle. And the last one is sine squared of angle plus sine plus cos squared of that angle is always equal to 1. Hope you enjoyed very well the lesson. Thank you and have a good day. Bye-bye.